Hello guys, I hope you are doing great. In this lesson, we will be discussing pulleys and we will be defining pulleys as a simple machine. So pulleys are used to help lift heavy objects made out of a wheel and axle and a rope that fits in a groove. So let's agree on something that a pulley is made out of a wheel and axle and a rope, and the rope fits in a groove. As you can see here, this is an example of a pulley, and this pulley is called a fixed pulley. And we will be discussing the types of pulleys in a later slide. So what is a pulley? A pulley is a simple machine that is used to change the direction. Be careful on the word change the direction. Not all pulleys can change the direction. A fixed pulley only can change the direction, but we usually use it in order to change the direction. In order to change the direction, you have to apply a force to move an object. The more pulleys you put together, when we put more pulleys together, which means we are creating a pulley system, it will be easier to us to move objects or to lift heavy objects. So pulleys work by using a wheel, as I said, and an axle. So pulleys, they work by using a wheel and axle and definitely the rope. So the axle is used to hold the wheel in a place. Okay, this is the axle, and we studied previously the wheel and axle. The wheel allows the rope to move around it smoothly, and the rope is pulled across the wheel and axle, making it easy to lift objects attached to the other side. As you can see here, this is a fixed pulley. We apply force to this end and the load will be lifted upward. So we change the direction, okay? And this is only in fixed pulley. Keep it in mind. Now, what are some examples of pulleys you might see in your daily lives? Okay, definitely you may have seen such as these objects like a flag. Pulling up the flag is a type of a pulley. The elevator works with pulleys. So many objects we see and know they work using pulleys, as you can see from these images. Now, pulleys are used when objects are too large or difficult to pick up by hand. So, why do we need pulleys? We need pulleys always and simple machines in order to make things easier for us, to make our life easier. And how a pulley can help us? When we have a large or difficult object to be picked by hand, we use a fixed pulley to allow us to change the direction. We use fixed pulley, as I told you, to change the direction. Okay, type. Instead of trying to lift an object from the side, a pulley will allow you to lift it from the top. Usually when you want to hold an object, you hold it with your hands from its sides. But when it's attached to a rope of a pulley, okay, as you can see here, we are lifting it from the top. So we are lifting it from the top. And as you can see here, we can use our weight in order to pull down. Okay, we use our weight to pull down. This is what makes pulleys easier, or this is how pulleys can help us. We can use our weight and the object will be lifted upward. So again, the types of pulleys are: 1, a fixed pulley; 2, a movable pulley; 3, a pulley system. A fixed pulley is a type of pulley attached to a supporting structure and stays in place. A movable pulley is a type of pulley that is able to move with the object being lifted. So a pulley is called to be movable. And the pulley system is when 2 or more pulleys are put together and one of them should be at least fixed and the other should be movable. Okay, so one fixed, one movable pulley. Now, let's talk about the fixed pulley. Changing the direction of the force. So we agreed that a fixed pulley will change the direction. We pull down, the object is going up. So that the forces are in different direction. And be careful that in a fixed pulley, the force is not changed. If the load is 200 Newton, then we need at least 200 Newton to be able to lift this object. Okay, so suppose you are trying to lift a 200 Newtons box using a fixed pulley, you must apply at least 200 Newton of force, and you use your body weight to pull the object down. As this guy in this photo, we use our weight in order to pull objects down. Now, these are again types of pulleys. This one is a fixed pulley. This one is a movable pulley, and together collectively they form a system, a pulley system, in order to pull this crate, for example. This is now a movable pulley, as you can see on the right. So when you put your effort to pull this rope upward, the object will move upward. So the same direction. You pull it up, the object will go up, and this is a movable pulley. The rope is here attached to the ceiling. So the load is attached to the wheel. As you can see here, the load is attached to the wheel, while in a pulley, in a fixed pulley, the object is attached to the rope. Okay, so in a fixed pulley, the object is attached to the rope. In a movable pulley, the object is attached to the wheel. The wheel moves up along the rope, and a movable pulley does not change the direction. If the effort is upward, the object will move upward. And the mechanical advantage in a movable pulley is about 2. Okay, definitely is about 2 if we are ignoring the friction force. So the mechanical advantage of a movable pulley is about 2. So the load is about 2 multiplied by the effort. So if you need, or if you have a 200 Newton load, you will be applying a 100 Newton effort. So if you want to calculate the mechanical advantage, it will be 200 over 100, we will get 2. Okay, so the mechanical advantage of a movable pulley is about 2. Now let's move to a pulley system. A pulley system, so we agree now, so it is a collective pulleys, a group of pulleys together. One of them is at least fixed and the other is movable. The more pulleys you put together, the higher the mechanical advantage. Okay, the higher the mechanical advantage, but the further you need to pull the rope, because you have more pulleys, and more pulley systems, so the ropes are longer. So the ropes, you need to pull them for a longer distance. Okay, so each extra pulley you put in this system will increase the mechanical advantage by 1. So in this, for example, in this system we have 5 pulleys. So the mechanical advantage, if we ignore the friction, is approximately 5. The mechanical advantage is approximately 5. Okay, so in a pulley system, the more pulleys you put, the mechanical advantage will increase. Okay, this is an example of a pulley system as well. We have here 1, 2, 3, 4, 5. So we can say that the mechanical advantage is approximately 5. We add more pulley, the mechanical advantage will increase. We remove 1 pulley, the mechanical advantage will decrease. Each extra pulley in a pulley system will help you increase the mechanical advantage by 1. So after we finish this part of the lesson, I'm going to give you some of the questions that you can write their answers in the comment down, and I can check them for you. The first question is, which pulley has a mechanical advantage equal to 1? Question number 2, in a movable pulley, if the load is 200 Newton, what would be the effort? Question number 3, why adding pulleys will reduce the efficiency? And question number 4, what will be the mechanical advantage of a pulley system with 5 pulleys? Let me one more time tell you that when we add extra pulleys, we have more friction, which means we will have more friction between ropes and the wheel. Between ropes and the wheel, more friction, less efficiency. More friction, less efficiency. Okay, so I apparently answered one of your questions. When adding pulleys, we will be reducing the efficiency, because we will have more friction, and we will have more pulleys. Okay, that's it for today's lesson. I hope I will see you in future lessons. Take care.